Wow, you're doing super well. So now, after creation and subsetting, the final piece of the Python lists puzzle is manipulation. These are ways to change elements in your list, or to add elements to and remove elements from your list. Changing list elements is pretty straightforward. You use the same square brackets that we've used to subset lists, and then assign new elements to it using the equals sign. Suppose that after another look at fam, you realize that your dad's height is not up to date anymore, as he's shrinking with age. Instead of 1.89 meters, it should be 1.86 meters. To change this list element, which is at index 7, you can use this line of code. If you now check out fam, you'll see that the value is updated. You can even change an entire list slice at once. To change the elements Liz and 1.73, you access the first two elements with 0:2, and then assign a new list to it. Do you still remember how the plus operator was different for strings and integers? Well, it's also different for lists. If you use the plus sign with two lists, Python simply pastes together their contents in a single list. Suppose you want to add your own name and height to the fam height list. This will do the trick. Of course, you can also store this new list in a variable fam_ext, for example. Finally, deleting elements from a list is also pretty straightforward. You'll have to use del here. Take this line, for example, that deletes the element with index 2, that is, Emma, from the list. If you check out fam now, you'll see that the Emma string is gone. Because you've removed an index, all elements that came after Emma moved over by one index. If you run the same line again, you're removing the element at index 2, which is Emma's height, 1.68 meters now. Understanding how Python lists actually work behind the scenes becomes pretty important now. What actually happens when you create a new list, X, like this? Well, in a simplified sense, you're storing a list in your computer memory and store the address of that list, so where the list is in your computer memory, in X. Now this means that X does not actually contain all the list elements. It rather contains a reference to the list. For basic operations, the difference is not that important, but it becomes more so when you start copying lists. Let me clarify this with an example. Let's store the list X as a new variable Y by simply using the equals sign. Let's now change the element with index 1 in the list Y like this. The funky thing is that if you now check out X again, the second element was also changed here. That's because when you copied X to Y with the equals sign, you copied the reference to the list, not the actual values themselves. When you're updating an element in the list, it's one and the same list in the computer memory you're changing. Both X and Y point to this list, so the update is visible from both variables. If you want to create a list Y that points to a new list in the memory with the same values, you'll need to use something other than the equals sign. You can use the list function like this, or use slicing to select all list elements explicitly. If you now make a change to the list Y points to, X is not affected. If that was a bit too much to take in, don't worry. The exercises will help you understand list manipulation and the subtle inner workings of lists. I'm sure you'll do great.